Welcome to Lesson 1. I remind you that this is a video and that the purpose of it is not to have a conversation with anybody, so it's going to go really fast. If you are getting lost, then you can pause, you can rewind, you can fast forward. I call that the power of video. So use the power of video as we go through this lesson. This beginning lesson is just an introductory lesson to chemistry. Part of the reason that we're doing this is to get used to Canvas, to get used to turning in assignments. So if it seems a little trivial, I guess maybe the content kind of is. It's not going to be on the final exam, but this is something that we're going to use to just give us some groundwork and lay a foundation for the rest of the class. So what is chemistry? What are we doing this whole semester? We are studying the composition of matter. So we're going to focus entirely on matter, and you can see the definition of matter there on the screen. I don't intend to read things like this to you. So there are 5 traditional types of chemistry, and you can see them listed to the side. I would like to point out to you some things to focus on whenever you look at this. And what I'll be doing is I will be writing, if I can, on the slides. I don't want to pause it. I will be writing on the slides from time to time. I apologize ahead of time for my handwriting. I will definitely try to make it legible. But the point of going through some of these and not just letting you read them is to make sure that you're focusing where you need to focus. So I'm going to ask you some practice problems in a little bit with identifying the different types of chemistry. Organic chemistry always has to do with things that contain carbon. Carbon is the key right here. Inorganic chemistry is what we're going to be doing. We're going to study chemicals that generally do not contain carbon. So it's almost as if it's not one of these other 4 types, it's inorganic chemistry. Biochemistry. Focus on the word or the prefix bio here. Bio is about living things, so like things that take places in organisms, like metabolism, homeostasis, cellular respiration, how your body processes things like insulin. It would be all of the living things, things that take place in living things. Analytical. Think about the prefix of this, like to analyze something. It's studying the composition of matter. You're focusing here on the composition, what something is made up of, determining its makeup, determining what something is. I think in my mind about things like forensic science, where they analyze things and try to figure out what the mystery substance was, and then they come back and tell you what it was. That's analytical chemistry. Physical chemistry, think of physics. Physics is about energy. So it's the study of like how fast things happen, energy transfers. We'll do a teeny piece of this when we get to the thermochemistry, but if you're focusing on words like rates, things like heat, if something's hot or cold or how much heat is giving off, that would be energy transfers. If you see any of those words in the practice problems, then you need to choose physical chemistry as your particular answer. Now, pure versus applied. You can read the words that are on the screen, but I do want you to be able to differentiate between pure and applied chemistry. We are doing pure chemistry. We are studying chemistry purely for the sake of knowledge. Either you chose to do this, someone told you that you should, but we're not going to use it to develop anything. We're not making a new shampoo. We're not making medicine. We're not doing anything applied with it. Aspirin's a great example of applied chemistry, so are most medicines. A lot of things that are around you are applied chemistry, like you're researching it with a practical goal in mind. And then, of course, we love technology. Okay, why are we going to study it? Well, it explains a lot of the stuff that's around us. In line with this one, it's used a lot for AP classes, especially AP Bio. Chemistry is a prerequisite. It is too for AP Environmental. A lot of the things that we study in these two have to do with chemistry, and chemistry is a good foundation for it. It's also pretty good practice at memorizing some things. Chemistry has a lot of rules, so be prepared to memorize. It prepares you for a career. If you have any interest whatsoever in a health career, if you want to be a doctor, a nurse, if you want to be a physical therapist, if you want to be anything in the medical field, you are going to be taking a lot of chemistry, and this class helps prepare you to do this. It also makes you an informed citizen, so you can't knock that. A couple of words here. I think these are pretty self-explanatory. Obviously, most of what we're going to deal with is microscopic. Like, you can't see atoms, and that makes this class a little harder sometimes because you can't see it. I can't draw some of these things for you. I can't show you literal atoms. So lots of times we're going to be using analogies, and I want you to make sure that when we do, you don't learn the analogy and not learn the chemistry behind it. So just be careful of that. Okay. You have probably had this in previous classes. It is the scientific method. You can see the steps to the scientific method right here and a definition up here in this corner. You need to know the steps of the scientific method. These two right here, actually let's start up here first. I want to look at hypothesis for just a second. This one is misunderstood lots of times with students because I think it's commonly interchanged for the word theory. Because we say the word theory like I have an idea, like, oh, I have a theory about why that happened. And what you really mean is you have a hypothesis, like you have a proposed explanation for why that happened. You don't actually have a theory. We use hypothesis as the explanation for what happens. For example, tomatoes grow larger on plants that are given fertilizer. That is a hypothesis. It's not a theory. Okay. So be careful with this word. The variables right here. There's two different words because, I mean, that happens sometimes in chemistry and biology. There's more than one way to say something. You need to know them both. I think the words manipulated and responding are better at giving you a self-definition. However, independent and dependent are often used a lot. So know them both. I have some practice problems for you too, identifying the independent and dependent variables. We don't need it as much in this class as we do for some of the AP classes. Like, I make my students look at variables and write a research paper after the AP exam is over with, and they have a really hard time identifying the independent and the dependent variable. The easiest thing I think of is to think of cause and effect. The independent causes something, and the effect is the dependent variable. And the practice problems explain to you how to do that in this fashion. So if you say, like we did with our tomato problems, the fertilizer causes the tomatoes to grow larger. I'm running out of room. Then the fertilizer is the cause. That is the independent variable, and the tomatoes growing larger is the dependent. Now you could say it the other way. The tomatoes growing larger causes the fertilizer, and that makes absolutely no sense whatsoever. So that tells you that it's a wrong way to say it. The cause goes first and then the effect is next because it's cause and effect. Okay, so use that to help yourself. And then obviously after you observe, come up with an explanation, you test it using these variables, like you create a process to do it. Then you have to analyze your data, draw a conclusion, and your results have to be repeatable. If it's not repeatable, it's not valid. So here's your steps. One of the things that you need to do too is make sure that you have a control in your experiment. The purpose of the control is to have a basis for comparison. So in other words, if you did the tomato experiment, you would need to have some tomatoes that aren't given any fertilizer so that you have something to compare them to. If you fertilize all of them, then you have no basis to make a conclusion. They're bigger compared to what? So, have a control. Okay, last little thing here I think is theories and laws. Here's the word theory again. Same theory I was talking about earlier. This means something different than it does in everyday language. In chemistry, a theory is a well-tested explanation. You're probably familiar with some of these things. There's a very well heard of one called the Big Bang Theory. There's the theory of evolution. There's the theory of relativity. There's all kinds of theories, but the idea is that they're well tested. And we typically don't say that you can prove things in science. You can disprove, but not prove to be true. You can support them, but they always stand to be changed because we're constantly learning new information, and things change over time. but they're definitely not just a guess in the dark. So don't think of them that way. It's not like, oh, I have this random idea. And then lastly, you have laws. And laws are basically rules of how the universe is going to react. Like Newton's laws of motion. You've heard of some of these before. Like, to every action, there's an equal and opposite reaction. Or, there's laws of, like, law of conservation of energy or mass. Like, that energy can neither be created nor destroyed. They're accepted ways of behavior. The theories help explain those. Okay, now, it's practice time. So if you'll click next, you should go on to the next part of the module, and you should have some practice with these problems. I went very quickly. It's our first intro lesson. You have a feel for what speed I'm going to use, and hopefully you're going to get a feel for what the practice problems will be like. If you have trouble, you are able to contact me through email. You can contact me through the Q&A for this module that was linked in your introduction to it in the intro to Module 1. And you can also send me a message through the Canvas inbox. So you have multiple ways to contact me. You also have the office hours, which are listed on the instructor information page. Right now, they're going to be Mondays and Tuesdays from 3:30 to 4:15 and Thursdays from 9:30 to 10:30 p.m. And we can adjust if necessary once I get some feedback. So go try the practice problems, see what you can do with them, and let's see how the first turn-in goes. Good luck. Let me know if you have problems.